Welcome to this lesson on the foundations of chemical calculations. We're just going to go through some basics and hopefully that'll lay a nice foundation for when you get to the more complicated stuff. Right, why chemical calculations are important. If we take a reaction that you see quite often, which is we take hydrogen and I add it to oxygen, we know that we're going to get water. Okay, but when we look at this reaction and we look at all the dots that are represented, we can see that there's not enough oxygens because I have 2 oxygen atoms and only 1 over there, so it's a problem. 1 can't have disappeared, which means we actually would create a second water molecule. But this is also a problem now because now I've got 1, 2, 3, 4 hydrogens and I've only got 2 over there. So really I need another hydrogen molecule, which means when we write this as a balanced equation, we have to have 2 hydrogens with 2 oxygens, and that's going to give me 2 waters. What this reaction is telling me is at the absolute minimum, I need to have 2 hydrogen molecules, which I'm going to react with 1 oxygen molecule, which is then going to give us 2 water molecules. The problem with this is that we can't work with individual molecules. They're way too small. So we actually work with a lot more. We work with a much bigger value. And we need to remember, because molecules are tiny, that there are millions and millions and millions and millions and millions, and trillions and billions and all those other big words, okay? So that gets us to the basics that we use. We use the concept of the mole. Okay, now the mole is a very important concept for us. The mole is like a placeholder. I'm going to compare it to the fact that you know that when we have a dozen eggs, we know that that means we have 12. So if I'm working with the dozen and I say to you that I want half a dozen eggs, you know that if I have half a dozen, okay, it means that there's 6. If I have 2 dozen, then it means that I have 24 because I've gone 2 times. I don't have to keep telling you that a dozen means 12. That's what the mole is in science. The mole is a specific number of particles. The symbol for a mole is little n, okay, and its unit is mol, okay? And it's a very specific number. Now, that number is known as Avogadros number. It's named after the Italian scientist who had lots of breakthroughs in terms of this sort of stuff. Now, that number is 6,02 times 10 to the 23 per mole. So what this number tells me is that if I have 1 mole of anything, and that could be people, not that there are that many people in the world, people, desks, chairs, whatever, it means that I have 6,023 times 6,002 times 10 to the 23 moles. That's a big number. To put it in context for you, if I had to have 6,002 times 10 to the 23 basketballs and I put them all together, I would create a new planet the size of Earth. If I took donuts, okay, and I had a mole of donuts, and I put these donuts all over the earth, so that's the earth, and I put all these donuts here, the donuts would make a pile 8 kilometers high from the surface of the earth, and that's covering the whole surface of the earth. So a mole's a very big number, okay? Which is also why we don't often work with the actual number of things. We work with a mole. The symbol for Avogadros number is Na. Avogadros number, N number. Good way to remember it. Okay? When we work with the mole though, we don't just work with this value, with Avogadros number. The mole gives rise to something called molar mass. Now, the molar mass is the mass of 1 mole of a substance, either an element or a compound, and we use the atomic mass from the periodic table to work those out. So that's why our periodic tables are our best friend. The symbol is capital M. The unit is grams per mole. So when I look on the periodic table and I see that copper is 63,5 for its atomic mass, it means for me that the molar mass of copper is 63,5 grams per mole. That means if I have 63,5 grams of copper, I have 1 mole of copper, which means I have 6,02 times 10 to the 23 copper atoms. Okay? Where else is the number of moles important? For molar volume. Okay, we'll get to concentration in a second. The volume of 1 mole of gas is molar volume. Okay? Now, generally we use a standard molar volume. Every gas has the same molar volume at the same temperatures and pressures. It's known as Avogadros law. At standard temperature and pressure, it is a constant. Okay, that constant is a value, 22,4 decimeters cubed. Molar volume also has a symbol V for volume. Okay, M for molar. The nice thing is this is the same for everything. Now, STP is the temperature of 273 Kelvin or 0 degrees Celsius, and its pressure is 101,3 kilopascals or 1 atmosphere. We also use number of moles when we look at concentration. Concentration is the number of moles per unit volume. Number of moles, N, volume, V. Okay, its symbol is little c, and its unit is moles per decimeter cubed. Okay, decimeters cubed because that's the SI unit for volume. We don't use liters or milliliters. We've done all this. How do we put it together? Now, the whole basis of chemical calculations is working with number of moles. So if we look at the number of moles, the first thing we need to consider is number of particles. We're going to use Avogadros number for that. And and that tells me the number of particles. So we can put those 3 concepts together using this equation. Okay, where number of moles is the number of particles we've got divided by Avogadros number. That tells me that if I start with the number of moles and I multiply by Avogadros number, it'll give me how many particles I have. If I know the number of particles and I divide by Avogadros number, it's going to give me number of moles. Straightforward. But number of moles also gives me mass, as long as I compare it to molar mass. So, number of moles, this is the mass given or the sample. So this is the mass of the sample. Alright, it's also in grams. And molar mass is what we work out from the periodic table. So, if I take the number of moles, multiply it by the molar mass, it'll tell me how much of the substance I have. If I take the mass that I've got divided by its molar mass, it'll tell me how many moles I've got. What about volume? Well, molar volume, we're working with STP and volume. These are related. Number of moles is the volume we have, so this is the volume of the sample, divided by molar volume. So if I know the number of moles and I multiply by molar volume, I'll get the volume of the gas. If I know the volume of the gas divided by molar volume, I'll get number of moles. If I have volume and I want concentration, well, they're related by concentration, number of moles over volume. So this is the first one where number of moles wasn't the subject to the formula. Okay, it doesn't matter. If I take number of moles, divide by volume, it'll give me concentration. If I take the concentration times by the volume, it'll give me number of moles. When we do chemical calculations, we always want to know number of moles for ratio issues. So being able to work out number of moles is very important. Once we know number of moles, we can work out anything else. We can work out mass, we can work out volume, we can work out concentration. Hopefully that helped. If it did, please subscribe to my channel and stay tuned for more videos.